Okay, we're going to work on our last lesson of the year on graphing. This is on graphing and shading. Okay, remember how to graph and then shade things? So we'll practice some real easy ones to kind of get us warmed up, and then we'll go to what they're really going to look like. All right, so your first example is just to graph x greater than 0. Okay, I want to go over this because a lot of them get them wrong. They think that x greater than 0 means to draw a line on the x-axis. When you have x greater than 0, it does not mean to draw a line on the x-axis. It means to draw a line down the y-axis, like this. And then greater than is to shade on this side of the y-axis. Okay, why is that? Because those two quadrants on that side have all x values that are larger than 0. It would not work to shade the other way, to shade across the y-axis, because then you're shading quadrant 2. Okay, in other words, you're shading the quadrants where all the x's are positive, and that happens in quadrants 1 and 4. So the next one, y greater than 0, that means you got to shade the quadrants where the y values are greater than 0. So that's going to be the one that goes along the x-axis here, and then you're shading quadrants 1 and 2 where the y-axis, all the y values are greater than 0. So what would it be the combination? What if you did x is 0 greater than 0 and y is greater than 0? Then what quadrant are you shading? Just quadrant 1, because that's where everything is positive at the same time. So I just want to clarify so you know which direction to go. All right, now here's where we're really getting to this stuff. Y less than 2x plus 3. So we just need to review how to graph the line 2x plus 3. What does the 2 tell us? The slope. Okay, and slope is usually rise over run, so that's 2 over what? 2 over 1. That means up 2 over 1. And then what is the 3? The y-intercept. Do you remember y equals mx plus b? Okay, this is the b part. So when you graph a line, you're going to start at the number 3. So you can just kind of go ahead and 1, 2, 3, sort of mark it off. And then the slope is 2 over 1, which means up 2 over 1, up 2 over 1. So then we're going to the best we can, go up 2 over 1, and then maybe something over here in quadrant 2. Okay, now usually we would connect like this. Okay, but not this time because it says less than. It doesn't say less than or equal to, it says less than. So how does that change something if it's only less than? Do you remember? What kind of line? Dotted line. Okay, so we're going to have a dotted line that follows that path. Okay, so it's dotted instead of solid now. And then less than means you're shading. I usually go to the top of my line and I go down. So I know which side of my my linear line to graph on. So less than means I'll be shading down here. If you don't like, you're a notability, so you could do it differently. You could maybe highlight or something. Okay, if you want to do a highlighter instead to show that you're shading that side of things. I don't care how you shade. Okay, if you like to use a highlighter. Okay, any questions so far? Okay, honest, Jay Lenny, this is not so bad, is it? Not, it is bad still? Okay. All right. Okay, here's the next one. All right, 4x minus 2y equals 10. Is that ready to graph? Why not? I don't have y by itself, so what do? Subtract the 4x, so that gives me, oops. Yep, it gives me negative 2y less than or equal to negative 4x plus 10. Now what? Divide by negative 2, and reach way back in your memories. What happens when you divide by a negative number? Flip the sign around. So greater than, and now everything gets divided by negative 2. So I'm going to have positive 2x plus, minus So y is greater than or equal to 2x minus 5. So on my graph, I'm going to start at negative 5. So 1, 2, 3, 4, 5. And then the slope is 2 over 1, so up 2 over 1 every time. And this will be a solid line because it does have the equal to part of it. So a nice solid line connecting with the good slope and maybe even mark off that it's starting at the number 5 on the y-axis. And now the shading is greater than. So I usually start on one end and I make sure I'm shading up. Okay, so greater than would be the upper portion, or if you wanted to highlight, you'd be highlighting that side to show your shading. All right, we good on lines? Okay, what's example 5? Okay. Question 5 is a parabola. How do you know it's a parabola? Okay, because it has an x squared. What does the 5 mean? Maybe if we looked at it a different order, maybe if you changed the order and wrote y less than negative x squared plus 5, maybe if you wrote it that way. Okay, what does that 5 mean? It's up 5, and then what does the negative mean? It's upside down. Okay, the parabola has been reflected upside down. So we're going to go up 5, 3, 4, 5. And our parabola just has to be sketched in this way. Except that it's less than and not less than or equal to. So what did I do wrong? And that needs to be dotted as well. Okay, so a dotted parabola. All right, so dotted parabola. And we'll have 5 labeled as the top. That's called the vertex. And when it's less than, then we are shading inside of the parabola. Okay, because that's lower than the parabola itself. So then you can go ahead and do your shading on the interior part. So the beginning of your homework is just going to be, nice, like one thing at a time. One line, one parabola. Then you'll move on to where you're graphing a system, which is this chapter that we're in. This chapter is about graphing systems. So we'll be graphing 2 things at the same time, or more. So let's look at example 6. What 2 things are being graphed, or what 2 types of things, what 2 types of shapes are being graphed in example 6? A parabola and a line, okay? Now the line is not ready to be graphed yet. So for my line, I'm going to need to get y by itself, which means 3y, oops. All right, 3y less than or equal to negative 2x plus 4. Right, and then we divide by 3. So y less than or equal to negative 2/3 x plus 4/3. So first I'll have a parabola that I need to draw. What's nice about that parabola? There's no extras to it. So where is it starting? Starts at the origin, starts at 0. So we'll draw our parabola. It's not dotted or anything. Okay, it's just a regular parabola. And we're shading on because it's greater than the parabola, we're still shading the interior. So you might think, well, wait a minute, last time it was less than and you're shading the interior, and this time it's greater than and you're shading the interior. How am I supposed to know? Okay, pick a point, any point on the parabola at random. So I'll pick this one in quadrant 1 and draw an arrow going up. And that's on the inside, so I know I have to shade the inside. If it was less than, I would draw an arrow going down, and then I'd know I needed to shade that arrow is on the outside of my parabola, so I'd need to shade the outside. So if you ever have a question, pick any random point on the equation and literally draw a vertical arrow up or vertical arrow down if it's greater than or less than. That will help you know which direction you're supposed to shade. All right, then we need to draw the line. The line starts at 4/3, so you'll need to estimate where 4/3 is. So if you have 1 and 2, your 4/3 will be a little bit higher than that. It does not have to be perfect, okay, but it should be between the number 1 and 2, not quite 1.5. Then down 2 and over 3 for our slope. Down 2 over 3, so here's down 2 and over 3. So I sort of mark it off, and then I can estimate that. And for that, I will be shading beneath. Now this has 2 intersection points. It has an intersection point in quadrant 2, and it has an intersection point in quadrant 1. And I need to be below that line. So I need to be above the parabola, but below the line. So I'm going to end up erasing the shading, because I'm in Notability that makes it easy. I'm going to end up erasing the rest of that shading because that shading was above my linear line. So I'm only going to keep the shading that is below the line and above the parabola. And so you end up with this little region right there. Now you notice I had left you a spot on your note paper called solutions. What do you think the solutions are? The intersection point. So here's where I'm going to need you to grab your graphing calculator. You'll know on your homework if it's grayed out or not grayed out, if you're allowed to use your calculator or not. So grab your graphing calculator, graph these two things, and find the intersection spots. Those are called the solutions. Okay, does anybody have the quadrant 2 intersection spot? Okay. Good job on your rounding. Okay, good. Negative 1.3 or 535 and 2.357. All right, that's that intersection spot. How about the one in quadrant 1? Does anybody have that one, Sam?
869 and 754.
Okay, great. All right, so we have our 2 intersection spots, and those are called the solutions. So then you would record those as your answers. 2.357, and the other one is 0.869, comma 0.754. All right, last 2. All right, look at example 7. Okay. All right, example 7. It says x greater than 0, y greater than 0. So those are the very first 2 things we talked about. What does that mean? Only where? Only in quadrant 1. X greater than 0, y greater than 0. So if you want it right at the beginning, okay, we are only dealing with quadrant 1 answers here. Okay, you're not going to extend outside of that. That's what this means. Okay, that we're only talking about quadrant 1 only. Okay, all right, then we're going to move on and get the other ones in their graph ready system. So we need to get y by itself for both of them. So for the first one, y is less than or equal to negative 2x plus 10. So let's graph that one. Y is less than or equal to negative 2x plus 10. So when you mark 10, just maybe count by 2s, 2, 4, 6, 8, 10. Okay, mark that off as 10. And then the scale of counting down 2 and over 1. So down 2 over 1, down 2 over 1. When you come down and hit, you're going to hit at 5. But we are only shading below and within quadrant 1. So don't extend beyond in your shading. Make sure that you are staying within that triangular area. So you actually have 3 corners. All right, you've got a corner at 0, 0, 0 technically. You have a corner at 5, 0. And then you have a corner at 0, 10. So we have 3 different corners going on for this region. When we add a fourth system, which we're going to do just now, the fourth equation, we're going to add a fourth corner. There's an equal number of corners depending on how many equations there were in the system. If the system has 4 equations, you'll have 4 corners. If the system has 5 equations, you'll have 5 corners. You need to find all of them. So here are the 3 so far. All right, and then we need to get our y by itself in the second equation. And so when we do that, we have y less than or equal to, we have negative 2/3 again, x plus 14 over 3. So now we have to estimate and draw this. Okay, 14 over 3 is a little less than 5. If it was 15 over 3, it'd be perfectly 5. So I need to estimate where I'm starting. So I'm going to estimate about right there. That's pretty close to 5. Okay, mark it and label it. Let's see, I maybe should make it a little smaller. Okay. All right, so I think I'm going to put, it's not quite 5, so it's 14 over 3. You do not have to be perfect, but you have to have an idea of where that is. And then the slope is down 2 over 3. And so down 2 and over 1, 2, 3, that's going to have me with a line that's coming down like this. So I've now created another corner, an intersection spot. That intersection spot right there, I need to figure out what that is. Okay, and we're not using our calculator on this one. This would be an example of one that would be grayed out where you can't use your calculator. Okay, no problem. We just need to use elimination or substitution or something since we can't use our calculator. All right, so let's look at the system. Here we go. This is it. I'll put a blue circle around it right here. What do you think? What system or what method would be best to solve that system? Elimination, I like it. How are you going to make it eliminate?
You make one term negative.
Okay, make the top line or the bottom line negative. Make something negative so that we can solve by elimination. Okay, all right, so that's what I'm going to do. I'm going to make the top line negative, so negative 2x minus y, and it's just equal to right now. When you're solving for elimination, you don't use inequalities, you only use equal signs. And then the other line would be regular 2x plus 3y equals 14. Say that again? Negative 10, thank you. Okay, so we'll cross out and eliminate the x's. That'll give me 2y equals 4. And if 2y equals 4, then y must be equal to 2. And if y is equal to 2, I should be able to plug that in back, and I figure out that x is equal to 4, which means 4, 2 is the solution to this little spot right here. That this is 4, 2. Oh, plus I have 0, 14. Now that blue line, should I shade above the blue line and do the triangle piece that's above it? Or should I shade below the blue line and do that sort of quadrilateral piece that's beneath it? Is this above or below? Look at the inequality. Okay, it says less than, so I should be shading below. So I'm going to use my eraser to get rid of all the other shading that I don't need. And so this is my answer. It's a 4-sided figure. And maybe I'll use black or something as a line to outline the figure. Okay, it is a 4-sided figure shaded on the interior. And remember, there were 4 equations. So there's 4 sides and there's 4 corners. So the solutions are all 4 of those corners. Where you see I have a line for you to write solutions, there are 4 of them. The solutions are 0, 0, 0 and 14 thirds, 4 and 2, and 5 and 0. So there are 4 solutions to this altogether, matching the graph that has 4 sides. I want to do one more of these with you, and then I'm going to give you 20 whole minutes to work on your homework. Okay, any questions on example 7 before we finish example 8?
How do you know it's 4 sides?
There were, there were 4 different equations there. The top line that highlighted has 2 of them, and then there's a third and a fourth. And because there's 4, there will be 4 sides. There will be 4 corners. All right, so same thing in number 8. There's 4 of them. So again, should be looking at a 4-sided figure with 4 corners. And once again, I'm limited in quadrant 1 because of the way that's highlighted. And so for sure, I'm in quadrant 1. All right, so then my job then is just to get this system ready to be graphed. And so x plus 2y less than or equal to 4 is not ready to be graphed. But when I move the x and divide by 2, I'll have y less than or equal to negative half x plus 2. Okay, when I get y by itself, it'll be negative half x. So I'm ready to graph that one. So plus 2, I'll mark that off. And my slope is down 1 and over 2, and down 1 and over 2. That gets me to 4. And I'll connect those. And less than means I shade beneath. So far, I have a triangular shape that has 3 corners. The corners are 0, 0, 0, 2, and the other one is 4, 0. So far, I have 3 out of my 4 corners. Okay, now the last equation, get by itself, but be careful. What do you have to watch out for in that last equation, x minus y is less than or equal to 1? What do you have to be careful of when you get that alone? Okay, I'm dividing it by a negative, which means I minus x on both sides. So I'm going to subtract x. That'll give me negative y less than or equal to negative x plus 1, which means I need to get rid of the negative, which means I need to flip the sign around. So I'm going to have y is greater than or equal to positive x minus 1. When you have positive x, what kind of slope does that mean? 1 over 1. Okay, so I need to graph that. So I need to start at negative 1, which means I need to extend my y-axis a little bit. I didn't quite give you enough. And start at negative 1. And then go up 1 over 1, up 1 over 1 consistently. So that's going to give you a line like this. And I need to shade above that. But I also only am allowed to be in quadrant 1. So do you see this? I'm going to draw an arrow to it. Do you see this tiny little, tiny little triangle right there that I've just drawn an arrow to? Is that part of the answer? That little white triangle. Will that be part of the answer? Why not? Kat shook her head. It's not in quadrant 1. Okay, it's not in quadrant 1, so it's not going to be part of the answer. So the answer will be bordered by the quadrant 1 lines. Okay, just put those, and then it'll be bordered here, and it'll be bordered here. So I'm going to use my eraser and erase this whole section that's not part of the solution. So I need to figure out where these corners are, because I have 2 more corners that I haven't included. So first, my red line is hitting the x-axis, and I need to know where that is. And then my red line is hitting the blue line, and I need to figure out where that is as well. So this is what we're going for right now. We are trying to figure out this corner, and we're trying to figure out that corner. It all has to do with where the red line is crossing. So I need to take my red line and set it equal to 0 because it's crossing the x-axis. And then I need to take my red line and make it equal to the blue line to find out where that's happening. Can't use my calculator. So here's the red line, x minus 1. Set it equal to 0. That's easy. X must be equal to 1. So that equation should be, that's 1 right there, 1 comma 0. The last dot is where the red and blue lines intersect. So that's x minus 1 equals to the other one, and the other one was negative 1/2 x plus 2. That's the blue line, that's the red line and the blue line intersecting each other. And so I want to solve for that, which means I add 1/2 x to both sides, add half x, add half x. That gives me 3/2 x minus 1 equals 2. Now add a 1 to both sides. So 3/2 x equals 3. And so x is equal, when you multiply both sides by the reciprocal, you get x to be 2. And if x is 2, y is 1. So this intersection spot right here is the number 2, 1. So I have 4 corners, and I should have 4 corners, I should have 4 sides because this equation had 4 systems in it. All right, what makes this problem different than the others was that in example 8 there was something else which I've kind of ignored so far at the very beginning. It says objective. Find the maximum value for the letter F. So what you need to do for your final step when you have an objective is to test all 4 corner points. So here's how I like to do it. I make an X, a Y, and an F chart, and I just test them all using the F equation that they gave me. So I test all 4 corners. I'm going to test the 0, 0 corner. I'm going to test the 0, 2 corner. I'm going to test 2, 1, and 1, 0. So those are all the x's from all the corners, and I'm going to plug them into the equation for f, which was given to me right up here at the beginning. F is equal to 3 times whatever x is and 2 times whatever y is. So you just take your numbers for x and y and plug them in. So if I plug 0, 0, I get f to be 0. If I take 0 and 2 and plug them into the f function, I'm going to get 4. If I take 2 and 1 and I plug them into the f function, I'm going to get 8. And if I take 1 and 0 and plug it into the f function, I'm going to get 3. And the objective is to find the what? No, find what about f? Find the maximum. So which one is the maximum for f? Okay, 2, 1, and 8. That's the maximum because 8 is the biggest number. So the answer is the max, whoops. Okay, the max for f is 8 at the corner 2, 1. Okay, so the max is 8 at the corner 2, 1. Did you guys all get where those f numbers came from, where I got 0, 4, 8, and 3?
No.
Okay, sorry, I went a little too fast on that. Okay, I took 0, 0, and I plugged it in for 0 and 0 in for x and y. So 3 times 0 and 2 times 0, which made 0. Okay, then I took 0 and 2, and I plugged those in for x and y. So 3 times 0 and 2 times 2, that gave me 4. Then I did the same thing for 2, and I did the same thing for 1. Does that make sense now, Rose? Okay, that's where I got those numbers from. And then because it said to find the maximum, then I picked the one that produced the maximum number. If it had said find the minimum, I would have picked a different one.